Yep. So just a review from yesterday, we have the different types of quadrilaterals. If you start off, you either have a parallelogram where you have two pairs of parallel sides, or you have a trapezoid where you have only two sides, which means one pair of parallel sides, or you have a trapezium where you have no sides that are parallel to each other. If you look at it, we have three special types of parallelograms. A square is a parallelogram that's regular. It's both equilateral and equiangular. A rectangle is a parallelogram that's equiangular. All four angles are the same. A rhombus is a parallelogram where it's equilateral. That means that all four sides have the same value. Now, a question we left off with yesterday. Are all squares rhombuses? Yes. Are all rectangles squares? No. But are all squares rectangles? Yes, because all squares have four right angles that are equal, and that's what the definition of a rectangle is. But definition of a square is that it's equiangular and equilateral, and are all rectangles equilateral? No. So not all rectangles are squares, but all squares are rectangles. So today what we want to talk about is the next lesson, lesson set 3. We're going to talk about perimeter and circumference. Do you know what those words mean? No. Perimeter doesn't mean anything to you? It does? What is it? Distance around an object. Okay. Circumference deals with circles. Circumference is the perimeter of a circle. If you talk about perimeter and you break it down into the Greek word, we broke down polygon. Poly meant what? Opposite. Many. Poly meant many, and gon refers to what? Angle. Angle. So here, when we talk about this, we talk about perimeter, and the word, let me get a different color. Can we do this? We can break it into two parts here. And if we break it down, Greek, if you look into the Greeks, peri, or the very first part of perimeter, that prefix, when you look at it, is going to mean around. So we are talking about the around. Meter means measure. So it's the around measure that we have, and that's what we want to look at. Given a polygon, maybe it's not even a polygon, maybe we just have a two-dimensional figure because we have a curved segment to it. That means that it's no longer a polygon. We want to be able to find the perimeter. Where would you have it? Why would you have to know the perimeter? Construction. You got to know the perimeter of something. If you're going to build a fence, you need to know how much supplies you need to buy, and you need to know the perimeter. What? You could guess, but what happens if you spend $1,000 more than you should have? Or less money than you bought it for. So perimeter is distance around an object or 2D figure. Perimeter, the distance around. So we're going to work on calculating the perimeter of different figures. did it. Without me in it, I hope. Here we go. Given this figure, find the perimeter of this figure. All angles are right angles. Dimensions are in inches. So we need the distance around. If I look at the distance around, you have to include every single one of those line segments. Now, some of you are going to sit there and try to calculate what that exact length is right there, because it's not given to you, but it is part of the perimeter. So you just can't say that it's 15 plus 9 plus 4 plus 5 plus 5 plus 3. You're missing some segments. I don't know that length that I have in blue, and I don't know that piece right over there. So there's 2 lengths that we are missing. However, I do know this much. Do I have to find it? If I had to find this, how would you find that? So you would say it's 15, and you're going to subtract the 4 and the 3 because the 15 is the full length, and you know you have this piece and this piece, right? What does that give you? 8. But wait, I'm finding perimeter. And if I am finding perimeter, what are you going to do to those pieces? Add them together. So you have 4 plus 8 plus 3. What's 4 plus 8 plus 3? 15. Did I have to find that exact value right there to be 8? No, you didn't have to. You did not have to. Don't go to all that work if you don't have to find those missing pieces. So we're going to use that same concept as what you used, Jameson, but we're going to say this length right here is 15. So what do I know about these 3 pieces right here? They add up to 15 as well, because I could slide this up here. If I take this and I slide it up and put it right there, it's going to have another length of 15. So I know that these pieces that I have in blue, I have 15 on the bottom. This bottom piece right here is 15. And then I have another 4 plus this length plus that length. And that's going to be how much again? 15. So I'm going to have 15 plus 15. What's that give you a length of? 30. So I have 30 so far. In my perimeter, I have this length of 9. What's this distance over here? 9. So I have 2 lengths of 9, which is the same thing as how much? 18. Last but not least, have I taken care of the whole perimeter? No. I have this line segment here, and I have this line segment here. Are they equal to each other? Yes, they are both 5. So if I were to add those 2 pieces together, I'm going to add another 10. I just look at it and I say 15 and 15. Oh, that's 30. I go directly to this right here, but you can write each one down separately if you want to. What's 30 plus 10 plus 18? 58. Now, what are your units? It's just inches. It's not squared, it's not cubed or anything like that. If I were to go around that object, it would be 58 inches. If I were to measure all the pieces around, I would need 58 inches of string to go all the way around. What happens though if you get to a figure like this? If you get to a figure like that, we have this curved piece. And it's not as easy because I don't know. I got to calculate what that length of that curved piece is first. So in order to do that, what we have to do is we need to talk about something called circumference. Circumference is just the perimeter of, oh, I better write the word out. Sorry, my shorthand there. It's the perimeter of a circle. when we come up with that, we have two specific things that we talk about when we are getting into circumference. There's two different formulas that can be used to calculate circumference, and I'm going to show you where they come from. But the first thing we need to understand is the term radius and the term diameter. Halfway what? It's from the center of the circle to the edge of the circle, or the circumference of the circle. That's your radius. What is diameter? It's all the way across, and here's the specific thing that you need, is it goes through the center of the circle. If it did not go through so that's your diameter. If it did not go through the center of the circle, for an example, I could draw that right there. That segment right there in blue is called a chord. And the diameter is known to be a special type of chord because it goes through the center of the circle. But if you talk about it as a line segment where its two endpoints are on the circumference of the circle, diameter has to go through the center of the circle. So what you need, note card, formula you need to know. Do you know what the formula is for circumference? One way that we can talk about circumference formula-wise is circumference is 2 pi r, or pi times diameter. Or you can learn it as circumference is pi times diameter. That's why we said you need to know what radius is and you need to know what diameter is. Now, if you put this on a note card, that now becomes a bookmark, and you have your formula right there for you, right? And you found the note cards. You want one. Jose, will you do me a favor? Will you go open that door, and back there is a bike wheel. Would you grab that and bring it in here, please? It's on the floor, I do believe, in there. Okay, as he's grabbing that, what we're going to focus on is figuring out what circumference means pi times diameter is. That's the first thing I want to look at. I'm going to go ahead and pause the recording because you're not going to be able to see what I talk about. So I'll pause it for a second. So what we have is pi. Pi, I'm going to use this double squiggly sign. Do you know what that means? That symbol right there means approximately. It's approximately equal to what you know it is, 3.14. Approximately equal to 3.14. Pi happens to be an irrational number. When we talk about our classifications of numbers, rational means you can write it as a fraction. Now, some textbooks do have an approximation for that as a fraction. They have a way of representing it, but it's not quite as exact. Irrational number because pi does not end, which means terminate. The decimal does not terminate. It keeps on going. Pi does not repeat. So that decimal value does not repeat. Because if you talk about 0.3333333333333, do you know what that is as a fraction? 1/3.
Repeating decimals can be written as a fraction and they become rational numbers. But if it does not repeat and if it does not end or terminate, then that means that it becomes an irrational number, and pi is in that classification of irrational numbers. Pi is the same thing as taking the circumference and dividing it by the diameter. Circumference divided by the diameter. And we noticed that when I did the wheel with the string. We took that diameter, wrapped it around the circumference, and it went 3.14 times. Approximately 3.14 times. 3 and a little bit more. Yes. I better not see pictures of me posted.
Oh, yeah.
Now you're going to go delete them, right? It's all right. You're fine. I'm standing up here by it. I was just teasing you.
You look amazing today, so he does.
Oh, well, thank you. I had to walk in with my coat up over my head because if my hair gets wet, it'll like kink and curl. Oh, you get my messy dust. That's all right. Sweet. You're doing good. You should have went with the yearbook today. Circumference. You get 15 seconds with a partner to come up with the two formulas. Okay. Your group. Give me one of them. Circumference is equal to 2 pi r. What's the other one? Diameter times pi. I don't care if you use a capital D or a lowercase d. Diameter times pi. Given this right here, the radius of a circle, the radius is 3 centimeters. They want me to find the circumference of the circle. Which formula do you want to use? 2 pi r. Circumference is 2 times pi times r. Diameter is twice the radius, remember. If you look back when we talked about a diameter, the diameter here in green is the same thing as 1, 2 radii. So diameter is equal to, they call it radii. It means the same thing as twice the radius. Diameter is twice the radius. So I don't care when you solve this problem if you use 2 pi r or if you use circumference is pi times diameter. But you got to find the diameter first. That's the formula you're going to use. Otherwise, we substitute in the information. 2 times pi, and your radius is 3. Now, when you multiply them, you have to simplify that. You can't just leave that as your answer. Garrett. Area. Area of the circle, because units for area are squared. So circumference is equal to, you can multiply the whole numbers together. 6 pi. Now you can leave your answer in this format. I don't care if you leave your answer in this format. Some of you are like, I have no idea what 6 pi is. How long is that? That makes no sense at all to me. Can you come up with an approximation? Yeah, because pi is approximately what? 3.14, but let's just say it's 3. What's 6 times 3? 18. So it's approximately 18 centimeters long. Is it a little more or a little less than that? A little more. If this were a multiple choice question, do you think you could narrow down your answer? If there were 4 answers, do you think you can narrow it down to possibly 2 without doing the calculation? Yeah, because I bet 2 answers are less than 18. I bet 2 of them involve taking 6 and or taking 3 and squaring it and making your number even larger. Now, if you want to know a closer approximate than just 18, go ahead and take 3.14 times 6. But what had you better do? You better do your multiplication right, because if you miss the multiplication part of it, you're going to get it wrong. So 6 times 4 is 24. 6 times 1 is 6 plus 2 is 8. And 6 times 3 is 18. Were we close by saying it's a little more than 18 centimeters? Yeah. It's not even a whole centimeter. It's just a little bit more. You know that if you had a value like 25, that's too much. Here's the other thing you could do, because as Garrett asked the question, when do you use pi r squared? Pi r squared is used when you're finding area. Some people remember pi r squared and pi times diameter. Diameter is for circumference because you see a CD and everybody knows what a CD is, right? Very good. And it plays music, right? Yeah. But we can at least see CD. And then when I have the R, pi r squared, that deals with area. But when I use the formula that has a D in it, that goes with circumference because it says CD and I know what a CD is. Or I can think of CD. You think of pi times diameter. The first thing you have to find is the diameter. If you know the radius is 3 centimeters, what is the diameter? 6. You double it. So the diameter is 6. Now you put it into your formula. It's pi times 6. That's the same thing we had over here when we said it is 6 pi. So my circumference is equal to 6 pi centimeters. And then you could go ahead and multiply that if you wanted to. Yes, Gary? Okay. I prefer to put the number in front of the symbol. Is there a difference? Okay, let me ask you this much. If I say Garrett would, or if I go would Garrett, why did you chuckle? Is it still the same person? Yeah, it's still the same person. It's just that I switched the first and the last name together. Have you ever filled out paperwork where the very first thing they say is write your last name and you accidentally put your first name down? Yeah, because you're not used to that. You always say your first name first. And it's not like you go up to a good-looking girl and say, hello, I'm Lund Jose. You don't say that, do you? You go, I'm Jose Lund. Nice to meet you. That's the difference between pi 6 or 6 pi. What's the last name in this case? The pi. Put the number first. Is there a difference? Now you still multiply them together. It's just which one is standard and easier to work with. This one. The circumference of a circle is 24 meters. Find the radius of the circle. A little more difficult. We see different words here. We see circumference. Do I know the circumference? Yes, the circumference is 24 meters. Then it says find what? The radius. Okay, so I'm working with something that says circumference and radius. Do you know a formula? Circumference is equal to 2 pi r. What information do we know? What did they tell you in the problem? This right here. The circumference is 24. Where does that go in this formula right here? In front of the equal sign. That's my C value. My circumference is 24. That's 2 pi r. What happens How can I get rid of this 2 over here? Divide by 2. I'm going to get rid of this 2 over here. So I'm going to take this by half and figure out what? 12. 12 is equal to pi times my radius. So your radius can be found by doing what? Dividing by. My radius is going to be 12, and I'm going to divide it by pi. That looks awkward, right? What are your units? Radius is a length that's going to be in meters. That looks awkward. But can you tell me what an approximation would be for that radius? The radius has got to be about what? About 4. A little more or a little less than 4? A little less. Because if I say this is 4, you're going to get 4 times 2 is 8, and 8 times 3 is 24. But this is pi is a little bit more than that, so it's going to make it a little bit more. So my radius would have to be just a little bit less to get to that 24. But we can do that. We can say, think of this, my thought. My thought is that this is 12 divided by 3. And 12 divided by 3 is 4. So it's approximately 4 meters. I have an idea of what it should be. If I were to answer it, I would put my answer in that format right there. You could say approximately 4 after. I'd probably give you that. Tomorrow, we are going to visit finding the perimeter of figures like this. We're going to look at 2 semicircles with more like a rectangle. We're going to deal with just words without a picture. How am I going to find perimeter? You need to draw the picture to help you with things such as this one. Yes? Sure. And then we're going to work with finding a side given the perimeter. So these are things that we are going to work with tomorrow. So be ready, understand perimeter. A good bell ringer question is probably you better know what the circumference of a circle is. That's a good formula to know. Or what does it mean when we say perimeter? No homework for today.